My dear students, my name is Shantaram, selection grade lecturer in mechanical engineering, government polytechnic, Karwar. Now we shall take up session 7 under unit 1. The topics covered are explain with PV and TS diagrams the working of Bell column and cycle of air refrigeration. In the session 6 we have discussed reversed Carnot cycle. Another air cycle very famous is a Bell column cycle. Cold air refrigerator working on Bell column cycle. Actually this cycle was used in Bell column and Hall refrigerator for freezing meat in Britain. The thermodynamic cycle employed in this case is a reversed Joule cycle. So which is in the heat engines we have discussed a Joule cycle, that's a reversed fashion. It is working here. Various operations of this cycle are explained in figure 2.3 and 2.4. So you can see the PV diagram as well as the working construction of a Bell column refrigerator. Air from refrigerating chamber is drawn into the cylinder of compressor where it is compressed isentropically and its pressure is raised to pressure of the cooler. So here we shall start from compressor. So air is drawn from the space or in the closed cycle from the evaporator and it is compressed and its temperature pressure increased, which goes to the cooler where it is cooled, and that process shown in on the PV diagram 1 to 2. It is isentropic compression. Next it is cooled in the cooler by exchange heat with a cooling medium, either water or air, and then it enters the expander where it is expanded isentropically, and that is shown by the line 3 to 4 isentropic expansion, and due to this the temperature and pressure of air gets reduced, and that to be required as in the refrigerator. Then that air enters the refrigerator where it is absorbs the heat from the surrounding, and then that air is sucked by the compressor and cycle repeats. Air from the cooler is drawn into the expansion cylinder where it is expanded isentropically to the pressure of refrigerating chamber. During the isentropic expansion, the temperature of the air falls considerably. This process is represented by the curve 3-4 on the PV diagram. The cooled air now enters the refrigerating chamber where it gains heat from refrigerating chamber at constant pressure till its temperature rises to T1. So temperature till it rises T1, it absorbs the heat. This process is shown by the line 4 to 1. Thus the cycle is completed. Here you have to note some important things. The heat rejected at the cooler will be equal to the sum of work done and heat absorbed from the refrigerated space if expansion 3 to 4 and compression 1 to 2 are isentropic. Bell column, so if it is isentropic, then the heat rejected is equal to heat absorbed plus work done. Bell column refrigerator may work on any one of the following systems: open system and a closed system. In open system, the air comes in direct contact with the refrigerated products in the cold chamber. So in open system, the cold air comes in contact with the foodstuffs and absorbs the heat. Whereas in closed system, or it is also called dense system, the air passes through the coils placed in the chamber and thus absorbs heat from the cold chamber without coming in direct contact with the products kept therein. Quite often the coil carrying cold air is kept in the brain tank. So whenever you require second refrigerant, that can be, you can use a brain or salt solution which is second refrigerant for uniform cooling purpose. The air extracts heat from the brain which is then circulated around the cold chamber. Advantage of closed system over a open system. Just now we have discussed the open and a closed system of Bell column cycle. So now we shall see the advantages of a closed system or open system. In open system, air picks up moisture from the products kept in the refrigerator space. So there is a chance of picking up the moisture. Second, in the open system, the expansion can be carried out only up to the atmospheric pressure prevailing in the cold chamber, but for a closed system, there is no such restriction. So you remember here the expansion available up to atmospheric pressure only, because that is available in the refrigerator chamber. So below that you cannot reach, whereas there is no limit for this in the dense system or closed system. So moisture may freeze during expansion and it is likely to choke the walls. So when moisture is picked up, then there is chances of choking of the walls. In a closed system, suction of compressor may be at high pressure, so you can keep a high pressure suction in closed system. The size expander and compressor can be kept within reasonable limits by using tensile. In tensile system, since we have the tubes and coils, therefore size can be restricted. In open system, it is not possible. So we shall now, as usual, have some multiple choice questions. Bell column refrigerator works on Rankine cycle, Carnot cycle, reverse Joule cycle, none of the above. Which is the correct answer? Option C, reverse Joule cycle. Question 2. The arrangement of Bell column refrigerator as follows: compressor, cooler, expander, refrigerated space. Second, cooler, expander, compressor, refrigerated space. Third, expander, cooler, compressor, refrigerated space. Fourth, D, none of the above. What is your answer? It is option A. Okay, question 3. In open air system, the cold air comes in contact with the refrigerated products, non-refrigerated products, outside products, none of the above. What is your answer? Option A, refrigerated products. Question 4. Closed system has the advantage of non-freezing of moisture in walls, less than atmospheric pressure can be maintained, the size of system can be maintained small, all the above. What is your answer? So all the above must be the answer. Question 5. The air refrigeration system requires power more than vapor compression, less than vapor compression, equal to vapor compression, none of the above. So from our earlier discussion, it is clear that air refrigeration takes more power. Therefore, answer is option A, more than vapor compression. Okay, you can further study in detail these topics by referring these standard textbooks. Hoping that you have understood the concept, we shall end up the session. Thank you.